We'd return to section R3, and here we are again, section R3, another part of it. Again, we'll come back to it again in a couple of weeks and do the last part of section R3. But this one is the one about multiplying polynomials. When we did R3 before, we talked about the exponent rules, that if you multiply, you add the exponents. If you do all those exponent rule things. And we're going to employ, we're going to use some of those as we do examples from this. But the basis of this is just multiplying it out and getting the final result. It's simplifying by doing the multiplying step and then adding any like terms that we might have to that. So it's really straightforward section. Got a few examples here that we want to go over. So we just want to multiply and simplify. That would be our instructions that, end goal, simplify as much as you can. So we'll start with one pretty simple, 3x parentheses 4x plus 5. Real simple problem. Algebra 1 kind of thing in high school, you look at that and say, oh, that's distributive property. And we're going to distribute whatever's out in front to both things in parentheses. So we're going to take this 3x and we're going to multiply it to each piece. So we multiply 3x times 4x, 3 times 4 would be 12. And then x times x, that's where x squared comes from. And then we say 3x times 5. 3 times 5 is 15. And then there's an x to put on there. And that's it. That's distributive property. Those are not like terms because one's an x squared and one is not an x squared. It's a plain x. So they're not like terms, so you can't put them together and make 27x to the third. That doesn't happen. So don't jump on that bus. So and do it the wrong way. Okay. All right. So another one really similar to that, just a little bit more complicated. You got a negative 5x squared out in the front, and then a parentheses with a negative 2x minus 8. Again, it's distributive property. You're going to hear me say it's distributive property a bunch of times today because that's what this is. That's what the whole multiplying polynomials part is distributive property. So we're multiplying negatives, negative 5 times negative 2 turns into positive 10. X squared times x would be x to the what? To the third. That's right. So there's 3 x's there. So that's x to the third. And then we have a negative 5x squared times a minus 8 or a negative 8. So that's negative times a negative. So that turns to a positive. And then 5 times 8 is 40. And then it's just x squared tacked on the end. And you've distributed that part that's in front. It distributes to everything that's in the next parenthesis. That's the name of the game. Even when there's more than one thing in front, like this problem, x plus 3 times x plus 4. I used to teach a thing called FOIL method. I don't do that much anymore just because you know how to do distributive property. That's really what this is. You're distributing this whole thing to both pieces. So it's like x times x plus 3 plus 4 times x plus 3. So I'm taking x plus 3 and multiplying it to each individual piece in the next parenthesis. And then that just makes distributive property again. So it's just double distributive property is what I call that nowadays. Since I've kind of evolved a little bit here on my teaching there. I had a professor in college, I got all the way to getting my bachelor's in math before someone told me that FOIL method is not a good method. You may have learned FOIL method in high school, and that's just this one times this, and then this one, and first, outer, inner, last. That's the way FOIL method works. Guess what? FOIL method only works when it's a binomial times a binomial. It doesn't work any other time. So you learn this big method for only certain kinds of problems. It's kind of like having you know, a tool that only does one job. You know, it doesn't really help you that much. Where you have some tools that can do multiple jobs, that can be helpful. So here, once we've distributed, x times x is x squared, x times 3 is 3x, and then here we're distributing a positive 4 times x is 4x, positive 4 times 3 is positive 12. Then right there in the middle, we got some like terms. We want to put those together. That would be the simplifying portion of today's lesson. And there you end up with a trinomial at the end there. Always looking to put the like terms together if you can, if they exist. Another, maybe x minus 7 times 2x plus 5. Again, it's distributive property over and over today. So I'm distributing x minus 7 to both of those terms. So that's 2x, x minus 7 plus 5 times x minus 7. And I'm writing out every step here. Obviously, if you can do some of it in your head, then do that. That's fine. I'm just writing it out for our benefit here. 2x times x is 2x squared. 2x times minus 7 be negative 14x. And then I'm distributing a positive 5 to both of those. So that'd be plus 5x minus 35. And then I've got some like terms in the middle. Put those together. 14x, negative 14x, and positive 5x. 2x squared minus 9x minus 35. Nothing too strenuous yet with this. It doesn't get much more strenuous. These things. Any questions, Terrence? Yes, sir.
My antennas got lost somewhere.
All right.
So if you don't mind, could you run back over C or either D? I don't care which one. I just need to make sure I have a clear understanding.
All right. Well, let's just go back through D there, and we'll, since we're right there, I'll undo everything I've done. And I'll go back here. All right. So, and not undos. All right. So we got multiplication happening here. So we're taking this first piece, whatever's in front, and we're distributing it to both or all of the pieces in the parentheses after it. So that would be taking x minus 7 times 2x. So I'm writing 2x parentheses x minus 7. And then plus 5 x minus 7. Okay, so that's taking this and distributing it to both of those pieces that are here. And that's those pieces. Okay? And then I'm just going to do that distributive property again, but on the individual pieces. So 2x times x is 2x squared. And then 2x times minus 7 would be the negative 14x. Right? And then I'm going to distribute this plus 5 to both of those pieces. So 5 times x would be 5x. And then 5 times negative 7 would be negative 35. Right. You got it from there? All right. And then from there, you just combine the like terms. So 2x squared minus 9x minus 35. Get it? Get it?
Okay.
All right. Good deal. All right. Example E. Let's do this one. 2x plus 7 parentheses 2x minus 7. Look very similar, but not exactly the same in each parentheses. But it doesn't matter if they look the same or not. You're still doing the same work. You're taking whatever's in the front and distributing it to everything that's in the parentheses after it. So that's going to be 2x times 2x plus 7. Then a minus 7 times 2x plus 7. I'm taking that front piece, distributing it to both pieces on the inside or all of the pieces on the inside, and then distribute from there again. So 2x times 2x, 2x times 7. And then the difference on this one is that you've got a minus 7 there that you're distributing. So you need to distribute that minus sign with it. So that'd be a negative 14x and a negative 49. Because it's negative 7 times positive 2 and negative 7 times positive 7. And then combine like terms. Look right here in the middle. You got those two. Positive 14 and negative 14 cancel each other out. So that it's just 4x squared minus 49. And that's the final answer. Okay. By combining those middle terms, they cancel each other out. But not anything, super exciting about that. But that is kind of a special set that we'll talk about in the next section of things to come. Okay. Example F. 6x minus 3, parentheses, and then another parentheses, 10x plus 11. So another binomial times a binomial. Doing a lot of these because you're going to see a lot of these. This is something that's fairly important for where we're headed in the next couple of sections. Need to definitely be able to do these. So again, distributing the first parenthesis, 6x minus 3, to both of these pieces so that it's 10x, parentheses, 6x minus 3, and 11, 6x minus 3. That'll be 60x squared minus 30x, 66x minus 33. So I'm just distributing, pieces in the parentheses. And then I'm combining like terms in the middle, if there are any. Negative 30 and positive 66 be positive 36x, and then a minus 33. Kind of where we're headed, to kind of give you a heads up, why are we multiplying so many of these out? Well, in the next section, we're going to take that boxed in answer and start with it and go backwards, and end up with this top part being our answer. We're going to work backwards in this minute. And I'm going to show you how to do that. It seems daunting at first, but it's not really that bad once you learn the rules. It's kind of like Monopoly. If you don't know the rules, it's a pretty hard game. If you know the rules and know what you can do, you can learn it pretty quickly. All right, so let's go to a little bit bigger problem. Say we had 2x minus 3 in parentheses. And then in the second parentheses, let's put a little longer problem. Let's put x squared plus 7x minus 9. 7x. All right. Looks different, but it's just the song's got a third verse. That's the only difference here, is that you're taking this part and distributing it to all three of those pieces. So x squared, parentheses, 2x minus 3, 7x, parentheses, 2x minus 3, and then minus 9, parentheses, 2x minus 3. So it's the same thing, it's just a little bit longer. And so it doesn't get any more difficult, guys. It just gets a little longer. So we just distribute the first piece, x squared times both of those pieces, 2x to the third minus 3x squared. Really easy on that one. And then a positive 7x times both of those pieces would be 14x minus 21x, or 14x squared minus 21x. And then we're going to distribute a minus 9, a negative 9, to both of those pieces. So that'd be negative 18x, and negative times negative is positive. 9 times 3 is 27. So again, it was a longer problem at the beginning. It was a longer problem in the middle. So that means we should probably have more like terms to deal with here. And we do. We've got some x squareds to put together. So that, the 2x cubed doesn't have anybody like him. So then we're going to put the x squareds together. So -3 and a +14 be 11x squared. And then we got -21 and -18, both negatives. So we're going to combine together to make a bigger negative number, be -39x. And then the 27 doesn't have any like terms. So we get that on the end. And there we have a polynomial at the end that we can deal with. All right. Let's get to some of the what they call special products out of this, and it's the same thing. It's called special products, but it's the same instructions. It's multiplied out. X plus 5 squared. What's it mean to square something? Two of the same thing. So that just means take x plus 5 times itself. Well, guess what? That's the same thing that we've been doing. It's no different. It's taking x plus 5 and multiplying it to those pieces. There are shortcuts to memorize a pattern, but honestly, in the time that it takes me to remember that pattern and then apply it, I can just do the multiplication and be done. So x times x, x squared, 5x, there's another 5x, and then there's 25. And then simplify, got like terms in the middle, x squared plus 10x plus 25. And we've got a polynomial, or trinomial in this case, out of that. So squaring just means multiply it by itself. Even when it's something like this, 2x minus 3 squared. It's a binomial. It's a binomial times itself when it's squared. Bless you. 2x minus 3, 2x minus 3. And then just do the math. It doesn't change any. The biggest mistake that you see in this is, folks, when you square a binomial, is saying, oh, well, it's 2x times 2x is 4x squared, and then 3 times 3 is 9. So it's 4x squared, or 4x squared minus 9. No, that's not what it is. Be careful of that. That's the most common mistake in this level of math is doing it that way. Just take your time. Remember, I'm just going to write it out twice and multiply. And that way you don't mess up that idea. Okay, so 2x times 2x is 4x squared. 4x squared is part of the problem, but it's not the, as easy as you want it to be. And then positive 9. So 4x squared. And then here we have a -6 and a -6. So that's a -12x plus 9. Those are commonly missed problems in math classes. I even, a friend of mine that I went to undergrad with, he was getting his doctorate this year, and we were talking about common mistakes in different levels of classes that we taught, and he had this. He was teaching a differential equations class, which is like calculus 4 is basically what it is. And this was a common mistake with his students, was doing this and not getting the correct answer. So it's common from my high school algebra classes. It's pretty common for folks to miss that. So if it's one that's missed a lot, really pay attention to those, because usually they're not that difficult. They're just missed quite often for really, I don't understand apparent reasons for that. All right, so let's look at another one that's fairly easy. And it's the same thing again. We're not doing anything different, but it's just a special product because you're taking, this times that, they look very similar. X squared plus 3x minus 3x minus 9. The like terms in the middle, what happens to them? They cancel out. Okay. So, but it's no different. The work's exactly the same. So, yeah, there are shortcuts to those that you can remember. Oh, if they match except for the sign in the middle, then the middle term is going to cancel out. Maybe that's a way of remembering that. But the work's still the same. You still got to do the work, either way. So the process of how you're working that problem is not changing. Maybe you got 5x minus 11 and 5x plus 11. So even when the minus sign is in the first one, they're matching, but the work's not any different than what I've been doing. I'm not going to change, what I'm doing here. I'm still distributing this to both of those pieces. 5x times 5x minus 11 plus 11 times 5x minus 11. 5x, yeah. So distribute again. It's 25x squared minus 55x plus 55x minus 121. 11 times 11. And then what happens to the middle terms? Don't forget that square. They cancel out just like previous one. And there we've got our answer. Okay. Nothing, just doing the work. Even, I'll scroll back over and still see that one. Where they get a little bit more difficult, maybe they take 5x to the third minus 6, and then a 4x to the second plus 7. Yeah, that's got higher exponents in it, but the work, the process, still the same. Okay. You're taking this entire first piece to both of those. So that's 4x squared times 5x cubed minus 6 plus 7 is 5x cubed minus 6. Distribute 20x to the fifth. Because you add exponents, 2 plus 3 is 5. And then minus 24x squared. And then on the second one, you got 7 times 5 is 35. X to the third. And then 7 times minus 6 is negative 42. And the difference here is that we don't have like terms. We've got here in the middle, we've got x squared and an x cubed. They don't go together. So you can't put them together. The only thing that I'm going to do that will help you later on is I'm going to put it in order from the highest exponent to the smallest. So I'm going to start with 20x to the fifth. Then I'll put the plus 35x cubed. Then the minus 24x squared minus 42. That's descending order is what that's called by exponents. That'll help us in the next section when we start factoring in just a second. Once we start factoring, if it's in descending order, it's a lot easier than if it's not. If it's not in descending order, it can still be done, but it doesn't follow the same kind of rules when it's not in descending order. So we want to try to put all our answers in descending order. When you look at the online exam, their answers are going to be in descending order. So that helps also keep your answers consistent with what you're going to be seeing in that on those exams. Let's do one more in this section, and then we'll move on. Last example of R3 for this time, x plus 2 to the third power. What's it mean to take something to the third power? Multiply it times itself. There's 3 of them. So that's x plus 2 times x plus 2 times x plus 2. Well, all that that's multiplication. Multiplication, remember, it's commutative, meaning you can do it in any order you want to, and it still works the same. So what I'm going to do is I'm going to do these two in the bracket there. I'm going to put those together first and get that answer. Okay. So that'd be x times x plus 2 plus 2 times x plus 2. I'm going to work that out. X squared plus 2x plus 2x plus 4. And that ends up being x squared plus 4x plus 4. And remember, that is still multiplied by the other x plus 2. So it's distributive property to get this part in the brackets done. We just did distributive property twice. And then here, the last step is distributive property again. So yes, it's a longer problem, but the process still the same. Nothing's changing about that, how we're doing it. Still distributive property. So we're taking x plus 2 to all three terms there. So it'd be x squared times x plus 2, 4x times x plus 2, plus 4 times x plus 2. Doing the same work again, just a longer problem. And that'll give us x to the third, 2x squared, 4x squared, 8x, 4x, and 8. Last step, put your like terms together. We got x squareds that need to come together, so that's x cubed plus 6x squared. And then we have plain x's that need to come together, so that'd be plus 12x and then plus 8. Not really any shortcuts to that at all. It's just distributive property and, kind of grit and grind kind of stuff. You just got to do it and work it out. Any questions about this first section that we've covered? All right. Well, one down, 3 to go. Stick in the first chapter of the book there. We're going to go to R4, and what we're going to be doing is factoring polynomials. Factoring polynomials. Factoring polynomials is the reverse of what we just did. Okay? Is what we're going to do. We're going to undo what we just learned how to do. We're going to start with the answer and get back to the original problem from R3. Okay? So there's some rules that I try to, if you'll follow these rules, you'll be better off in factoring. It may not, always make it easy for you, but it'll make it as easy as it can be. So my rules of factoring. The number one rule is that the problem is in descending order. And again, you're going to look at the exponents to get there. Okay, descending order. So that means you need something like x squared, then plain x's, and then the numbers. Okay, so descending order. The number two thing that you want to follow with that, if it's in descending order, the next thing you want to look for is what's called the greatest common factor. And you'll hear me call this the GCF. So greatest common factor, that's the number or variables or combination of those that everybody shares. So like the numbers 10 and 15 have a greatest common factor of 5, because 5 is the biggest number that goes into 10 that also goes into 15. So we'll work with greatest common factor quite a bit. It's really the muscle behind all of the factoring that we do is greatest common factor. So we'll look at it quite a bit as we're going through here. Now, once you've looked for the greatest common factor, you factor that out. We'll see how to do that in just a minute. And then the next thing you want to do is look at how many terms there are. So third thing you do is count terms. And this is going to tell you how or what method you're going to use to factor a polynomial. If there are 4 terms, you're going to use this method called grouping. And I'm going to teach you how to do each of these methods or review you over that. Hopefully you've seen some of these before. If you haven't, it's okay. You can learn them today. They're not that bad. If there are 3 terms, it's a trinomial that we're dealing with. I use this thing called an X method, and I'll teach you how to do that. Some of you may have learned to factor polynomials in high school, and you may have learned guess and check, which is the way that I learned it. But the X method kind of takes the guessing out of it, a little less guessing involved, a little more process that it works every time. Where a guess and check, you have to pick a couple of numbers and then see if they work. And it doesn't necessarily, it's not the fastest method. Guess and check is not, if you're not good at it. If that's all you've ever done, you end up getting good at it. But once I learned this method when I was actually in college, before I learned this way of doing it, far better than guess and check. So I'm going to teach you how to do that. Really handy way of doing it. And then if there are 2 terms, you want to look for what's called a difference of squares. And I'll show you what that is. Or a sum or difference of cubes. And I'll show you how to do that as well. So we're going to go over all of those things. So 4 terms, we're going to try grouping. 3 terms, we're going to learn this method called the X method. 2 terms, we're going to try to do a difference of squares or a sum or difference of cubes. Those are easily discernible. Cubes are going to have an exponent of a 3. Squares are going to have an exponent of a 2. So that makes it easy to tell which one you're looking for there. Let's start with the first 2 rules there and kind of work our way up to doing the rule number 3 as we go here. So first thing, we're just going to call this factor the polynomial. First example is this, 5x plus 10. Real simple, short polynomial. The first thing you want to decide is it in descending order by exponents on the variable? Well, that's, what's the exponent on this x? It's a 1. There's not even a variable here, so that is in the right order. So we're good there. We don't have to rearrange it. The next thing we want to look for is the greatest common factor. So we want to look at the terms and say, okay, what do 5x and 10 have in common? They're both divisible by what? By 5. So that's the greatest common factor. So what we're going to do is we're going to pull this greatest common factor of a 5 out in front. It's just a plain 5, no x or nothing with it, because both of them don't have an x, so it can't be common if they both don't have it. The next thing we want to do is open up a set of parentheses, and we want to see what times this 5 gives me 5x. X. What times 5 would give me plus 10? Yeah, and it'd be a plus 2. The 5 is the GCF. The x plus 2 is what's left over. That's the factored form of that polynomial. Okay. So that's using greatest common factor. GCF is all we used on that one. We don't go any further there because there's not anything left to do. X plus 2 doesn't factor any further because it's just plain X there. If it were X squared and some things, we might look at it. But in this case, it's not. Look at this one, 6x squared plus 8x. Okay. Check for descending order. So we got x squared first and then plain x. That's 2 and 1. So that is in descending order from left to right. Biggest exponent is first. Okay. The next thing we want to look for is the GCF. 2. What else do they both have? They both have x's. The first term, the 6x squared, that has 2 x's. The second term only has 1 x. Okay? So they have 1 in common. They share 1. Okay? So 2 is what 6 and 8 have in common, and an x is what x squared and x have in common. The next thing to do is open up a set of parentheses and say, okay, what times 2x would give me 6x squared? 3, and we need another x. And what times 2x gives me plus 8x? A plus 4, yeah. And we don't need an x on that 4 because it's already out here. And we've got the factored form of that using GCF. Negative 15x squared plus 10x to the third. First thing we want to check for is what? Descending order. Is that in descending order? No. Mm-mm. So rearrange it so that it is. So all you got to do is just swap places with them. 10x cubed minus 15x squared. So just rearranging that into the descending order. It's going to help you. It's not as, this one could easily be done without doing that, but it does help you when they get bigger. So that's why that's one of my number one. That's my number one rule because it does help a lot when it gets larger. Okay. What do 10x to the third and 15x squared have in common? 5x squared. 5 goes into 10 and 15. It's the biggest number that goes into those two. And then this one has 3 x's. This one has 2. So that means they got 2 in common that they share. Okay. So what's left in the parentheses then? 2x. 2x minus 3. We've factored that polynomial by greatest common factor. Nine x to the fifth plus x squared. 9x to the fifth plus x squared. Is it in descending order? Yes. Yeah, so we're good there. We don't have to do anything. So then we need to look, okay, what's the GCF of those two? X squared. They don't have a number in common. Well, technically 1, but that doesn't help us any. But x squared is what they've got in common. So I'm putting x squared out in the front. And what's that going to leave in the parentheses? 9x to the third, or x cubed, plus what? It would be a 1 because the only way to get x squared back is multiply it times 1. What we should be able to do here once we factored with GCF is do distributive property with our answer and get the original problem back. That's the way of checking this. Is if you can do distributive property and get the original problem back, you're on the right track. So first one had 5x's. We used 2 of them in the GCF, so that left 3. So that's why it's 9x to the third. The second piece, x squared, we took the whole thing out. Well, we got to have a representative for that in the parentheses, and the 1 is what represents that. So if you ever factor out the entire thing, it's a 1 left over. Okay. Now, this continues even when it gets larger or has more than one variable. If you had 6x squared y plus 8xy plus 12y. So a 3-termed problem. Now, the problem with this one is the fact that it's got 2 variables. So descending order is kind of one of these things that it's hard to tell. This one's a little better because you got x squared, and then you got a plain x, and then you got something that doesn't even have x. So we could go by descending order on the x's for this one, and it'd be okay. So that's usually what you would do if you're trying to do descending order, is pick one of the variables to go by, and it's usually the first one in the alphabet. So if it's got A's and B's, you use A to go by. If it's got X's and Y's, you use X to go by because it's first in the alphabet. That's kind of my OCD answer for you. That's what I do. It really doesn't matter which one you pick, but that's usually the best method to take. So on this one, is there a GCF between all 3 terms?
2.
2 goes into 6, 8, and 12. And then y is on everybody. So y is the variable that they have in common. So 2y would be the GCF. And then our parentheses are going to have 3 terms left in it. So what times 2y gets me 6x squared y? 3x squared, and then plus 4x, good, plus 6. Yeah, good. And we've got that factored by GCF. Now, let's get into using the third rule. So we've used descending order and greatest common factor so far. Let's get into using the third rule, and we're going to start with the biggest problems because being able to do the 4-termed problems really helps in being able to do the smaller ones, believe it or not. So we're going to start with the grouping method. So this is grouping. All right, so I'm going to show you how to do grouping. And grouping is just GCF done twice. It's kind of like multiplying the binomial times a binomial. It's just distributed property twice. Grouping is just GCF twice. Okay, so let's start with this problem. X squared plus 6x plus 3x plus 18. And I know the 2 in the middle are like terms, but don't put them together. There's a method to my madness here. Okay, so I know the 2 in the middle are like terms, but don't put them together. We're trying to break it apart. So that's why you don't want to put them together here. All right, so we look at that and we say, okay, we got x squared, we got 6x, we got 3x, and then we got 18. So it's in descending order. It's in the right order. Is there a GCF across the whole problem, across all 4 terms? We look for that next. Well, 6, 3, and 18 have something in common, but the x squared that's in the front messes it up. So we can't take anything out of that. So the next thing to do is look at it and say, okay, there's 4 terms. There's 4 terms, tells us to do grouping, and this is how grouping works. Grouping takes the first 2 terms together, and we get the GCF of those 2. What do x squared and 6x have in common? X. And in parentheses, that would leave x plus 6. Then we look at the next two terms, and I'm going to underline those two. What do 3x and 18 have in common? What kind of 3? Positive. Here's the clue on grouping. Whatever sign is right there, that'll tell you what kind to pull out. If that were a minus sign there, we'd pull out a negative. And we're going to do some examples where that's going to happen. So I want to indicate that that sign that's in front of that third term tells you that it should be plus 3. And then what's left over after you pull a 3 out? 3 times what gets me 3x? It'd be x. 3 times what gets me 18? 6. Look at those parentheses. They match. They should. If everything worked right and you did it correctly and it factors, then those parentheses match. If those parentheses don't match, go back and make sure you got the GCF. You may not have gotten the biggest number. Okay? So make sure you get the GCF. And then here's how it works. Really quick GCF type problem. You're looking at, okay, well, one factor is x plus 6. That's the matching parentheses. The other factor is the stuff that's in front. And that's the factored form of that polynomial. Okay. All right. The matching parentheses will be your first factor, the first set of parentheses. The stuff that's in front will be your second parenthesis. And you've got it factored. That's what grouping does for you. It's GCF twice, and then you got your matching parentheses, and then the stuff in front. Okay. Let's look at this one. 4x to the third plus 2x squared minus 2x minus 1. Going down through the rules of factoring, is it in descending order? That's number 1 rule. Yes, it is. Okay. Number 2 rule is greatest common factor. So we're going to look across all 4 terms and say, okay, is there something that's in common between all 4 of them? No. Okay. That minus 1 on the end kind of kicks out any kind of GCF that we might have. So there's not a greatest common factor. The next thing to do is say, okay, how many terms does it have? It's got 4. So that tells us to do what method? Group. So I'm going to do grouping here. First 2 together, second 2 together. Okay. So I'm looking for the GCF of these first 2. 2x squared, good. What's that leave in their parentheses? 2x plus 1. All right. Now, second pair, negative 2x and negative 1. What do they have in common? Yeah, there's no bigger number. 1 goes into both of them. And then because this is a minus sign, it's going to be a negative 1. And this is where you've got to be kind of clever and say, okay, well, what times negative 1 gets me negative 2? Positive 2x. What times negative 1 gets me negative 1? Positive 1. It changes the signs of both of those things. So these were both negative here. When I factor out the negative, it changes their signs. What does that do to our parentheses then? Makes them match. Yeah, and that's what we want to happen, is them to match. Because these match, that means I did it right. And my factors, the first one is the matching parentheses, 2x plus 1. The second one, stuff in front. 2x squared minus 1.
And on a test or on a lab, if the answer was flipped, like, would that make a difference?
No, it's the same. If you had 2x squared minus 1 times 2x plus 1, like in the other order, then that's the same answer, because multiplication is commutative there. So it doesn't matter what order you write those two parentheses in, as long as the parentheses are those. Those are your factors of that. Let's say we had 10x squared minus 6x plus 25x minus 15. Another one of those where the two middle terms would normally go together, but we're trying to, factor here. So we want trying to break it apart. So we don't want to put them together. So is it in descending order? My exponents? Yeah, we're good there. Okay, we got x squared, we got minus 6x, positive 25x, those same levels, so it doesn't matter what order they're in, then the minus 15. So we're good there. Is there a greatest common factor across the whole problem? No. The 6x messed it up on this one, because it doesn't, 5 goes in everybody else, but not the 6. So the next thing to do would be say, okay, well, it's got 4 terms. I'm going to group it. First two, second two. What's the GCF of the first two? 2x. What's that leave in parentheses? 5x minus 3. Good. The second pair, 25 and 15. Remember that plus sign there says it's going to be a plus sign there. What do 25 and 15 have in common? 5. What's that leave in parentheses? What do you know? The matching parentheses. Yeehaw, we did it right. 5x minus 3 and 2x plus 5. Okay. Yes, sir.
This is being recorded, right?
Yes, sir.
Okay, I have an emergency at work and I need to go.
Okay, I'll post the links to it on Canvas so you can watch and catch up. That'll be fine, Terrence.
Okay, thank you
All right.
so much. I apologize.
Oh, that's okay. All right. Let's look at one that has more than one variable in it with the grouping method, and then we'll move on to the next method, which you'll see is exactly the same. So mp squared plus 7m plus 3p squared plus 21. All right. So here we got one that's got more than one variable in it. And, here descending order gets a little mushy here because, you got m's and p's and some of them have m's and some of them don't have m's and, some of them have a p squared and some of them don't have a p at all. So we're looking at it and we're saying, okay, I'm gonna put all the m stuff first and the stuff that doesn't have m's after that. That's what order I wrote this in. That's the kind of the order that I'm trying to go for here. You shouldn't have to rearrange any of these with multiple variables at all. When you get one, if you get one on the test, or if you're looking at one on the lab or in your textbook for practice, you shouldn't have to rearrange any of those. So look at it. You say, okay, well, I'm going to follow the rules, descending order, and kind of throw that out the window. And then say, okay, what's the greatest common factor across the whole problem? Well, there doesn't look to be one. So I don't have that. So the next thing I want to do is say, okay, how many terms do I have? I've got 1, 2, 3, 4 terms out of this. So I want to do grouping. So I group the first two together and then the second two together. What's the GCF of the first two? M. They both have an M and nothing else in common. So that's M, and then what's that leave in the parentheses? P squared plus 7. And then the second two, we got 3p squared and 21. It's a plus right there, so that's a plus in the middle. What do 3 and 21 have in common? 3. P squared plus 3 times what's 21? 7. What do you know? Matching parentheses. Did it right again. So we got p squared plus 7 and m plus 3. The factored form of that. And again, that could be rewritten, m plus 3, p squared plus 7. Those are the same. Remember that it doesn't matter what order the factors are written in. It's still the correct answers there. Okay, so we're looking at factoring here. 4 terms is going to tell us to group. And grouping is just GCF twice. So everything stems back to being able to find the GCF between terms. If you can do that, then the rest of it is easy. Okay. Let's look at the X method next. Okay. One of the kind of pillars of being a mathematician is the fact that we are boring and we try to make everything look like something we've already done. Okay. So what the X method at its root is trying to take a trinomial, something with 3 terms, and turn it into something with 4 terms. Okay? So if we can take a trinomial and turn it into something with 4 terms, then that allows us to do grouping, which allows us to use the GCF, which we already know how to do. So that's kind of the idea of math classes is you're going to try to turn something into something you know how to do. And that's one of the reasons I like math is because you can just kind of work with the problem until it turns into something you've seen before. And then you kind of remember, oh, I know how to do that. Maybe I didn't know how to do the original problem, but I worked with it until I got to something I need to do. So the way the X method works is you're dealing with what looks like trinomials. So it looks like this: ax squared plus bx plus c. A, B, and C are the numbers. And we'll do an example with numbers really soon. Okay. The X method, what you're going to do is you're going to make a big X. And in the top part, you're going to say A times C. And you're going to get a number for that. In the bottom part, you're going to put whatever B is, the number that B is. Okay. And then we're going to try to find the pieces that go on the side of the X. All right. That's what we're going to do here. We want these 2 numbers on the sides. They need to multiply to be A times C and add to B. Okay? So let's example J, and we'll do a quick one here. X squared plus 7x plus 12. Okay? There's a trinomial. We're going to try to turn this trinomial into a 4-term polynomial. So I'm going to make my X. What's A on this problem? What's in front of X squared? It's 1. What's C? C is 12. So in the top part of my X, I'm going to say 1 times 12. 1 times 12 is 12. So that's what goes up there. In the bottom part of my X, I'm going to put whatever B is. What's B? 7. Okay? So 1 times 12 goes in the top. That's 12. 7 in the bottom. I need 2 numbers that multiply to be 12 and add to be 7. Okay? So I'm thinking, okay, what numbers do I know multiply to be 12? There's 6 times 2. 6 times 2 is 12, but what's 6 plus 2? 8, not 7. So that's not the right ones. What else multiplies to be 12? 3 times 4. 3 times 4 is 12. What's 3 plus 4? 7. 3 and 4 are my numbers that are on the sides. That's what I want. Here's what happens with those. They replace the 7x. Okay? So we're just changing the way the problem looks. It started with a 7 in the middle. Now we've got a 3x and a 4x in the middle. Well, what's 3x plus 4x? It's 7x. So we've just kind of just manipulated the problem to make it look like what we want it to look like. We didn't change it really because it still ends up being, if we simplified it, would be back to the original. Okay? Once we've done that, we're back to grouping. First two together, second two together. What's the GCF of the first two? X. That leaves x plus 3. What's the GCF of the second two? 4. Positive 4. That leaves x plus 3. What do you know? Matching parentheses. That means I did something right. My factors are x plus 3, x plus 4. Okay. So it's taking that guess and check method that you may have learned in high school and putting a process to it that it's a little bit more straightforward. Really works better on a problem like this, example K, where we have 4x squared minus 11x plus 6. This is a really a good one for the X method to work on, okay? So here we've got a 3-termed polynomial. Is it in descending order? Yeah, we got x squared, we got x, we got no numbers, or no x's, okay? Then we look at it and say, okay, is there GCF across all 3 terms? No, that 11 messes it up. The 4 and the 6 would have got a 2, but the 11 screwed that up, okay? There's always that guy, okay? Now, the next thing to look at it is say, okay, it's got 3 terms. That means I'm going to do the X method. What goes on the top of the X here? 4 times 6, A times C. So whatever's in front times whatever's in the back. 4 times 6 would be 24. It's important to make sure the sign stays with it. So 4 times positive 6 is positive 24. What goes in the bottom? Negative 11. It's a minus 11 in the middle, so it's a negative 11 in the bottom of the X. That's a little bit more difficult because we need 2 numbers that multiply to be a positive number but add to be a negative number. What do we know about both numbers then? If they multiply to be positive but add to be negative. What? 1 negative and 1 positive would give me a negative product. They would multiply to be negative. If it multiplies to be positive, then the signs have to be the same. So if it multiplies to be positive 24 and adds to be negative 11, then both of them have to be negative numbers. Okay. If it multiplied to be positive, added to be positive, like example J did, then they both are positive numbers. So if it multiplies to be positive, signs are the same. If it multiplies to be negative, that's when they're opposites. One's positive, one's negative. So we need a number, 2 numbers that multiply to be 24, add to be 11, or negative 11. Better way of describing that. Negative 6 and negative 4. Negative 6 times negative 4 gives me the 24, but what's negative 6 plus negative 4? It'd be negative 10. Really close, but not quite. Okay? So negative 6 and negative 4 doesn't work. Let's try something else.
3 and 8.
3 and 8 would be, yeah, negative 3 and negative 8. And it doesn't matter which one you put on which side. Negative 3 and negative 8 multiplies to be positive 24. Negative 3 plus negative 8 is negative 11. That's the right 2 numbers. So that's what I'm going to replace the negative 11x with. I've got 4x squared I'm going to put the minus 8x first, then minus 3x plus 6. It does not matter what order you put those in there at, okay? If you wanted to put the minus 3x in the front and then the minus 8x, that's fine. It's not going to mess it up at all, okay? It'll just change your order a little bit on your factors, but it'll still give you the same two factors. Doesn't matter what order you put those 8x and 3x in there as. I just put the 8x in the front because I saw it goes with 4x. 8 and 4 is pretty easy to do. 3 and 6 is pretty easy to do. So that's what I'm looking for when I do that. Then I'm going to group it. First two together, second two together. GCF of the first two. 4x. Leaving x minus 2. Good. GCF of the second two. Minus 3. Remember that sign right there is going to tell you what to pull out. So it's a minus 3. So that's going to leave us x minus 2. Remember, it changes the signs on the inside. Parentheses match. Yay. Matching parentheses is one factor. The stuff in front is the other. So at grouping method, and this is the kind of problem that the guess and check method really started to get long on, because how many different ways are there to multiply to be 4x squared? You could have 4x times 1x, or you could have 2x and 2x. So there's two different ways to get 4x squared. And then how many ways are there to get 6? There's negative 3 times negative 2. There's positive 3 times positive 2. There's positive 6 times positive 1. There's negative 6 times negative 1. There was a ton of ways that you could guess and get the factors wrong. When I was learning this, we just opened up two sets of parentheses and started putting numbers in there and see if they'd work. And you just had to multiply a bunch of stuff out. That took a while. This doesn't take near as long. In the long run, it doesn't. If you guessed right the first time, hey, wonderful. 6n squared minus 7n minus 5. All right. So X method again. What goes up top? Which would be negative 30 and negative 7 on the bottom. So here we have multiplying to be a negative and adding to be a negative. So if you multiply to be a negative, you know that the signs are opposites. One's positive, one's negative. And we just needed to add to be negative 7. So we need to think things that multiply to be negative 30. First one that jumps in my mind is 6 and 5. Negative 6, positive 5. But that adds to be negative 1, not negative 7. So that doesn't work. Yeah, negative 10 and 3. That's the ones. That's the right. Doesn't matter which side you put them on. If you want to put the positive 3 first, fine. Negative 10. Negative 10 times 3 is negative 30. Negative 10 plus 3, negative 7. We've got the two numbers. Those two numbers do what? Replace 7n. That's right. I'll put an X in. So doesn't matter which one you put first. I'm going to put the 3 in first because I know it goes with 6 and that's easy to do. So I'm going to put plus 3 in. And then I'm going to put minus 10 in, minus 5. It doesn't matter. If you put the minus 10 in first, you'll end up with the same answer. Your in-between step look a little different, but the final answer will be the same. Then I'm going to group. 6n squared and 3n have 3n in common. That'll leave you 2n plus 1. And second group, Got a minus sign, so I know I'm going to pull a minus. 10 and 5 have 5 in common. That'd be 2n. Negative 5 times what gets me negative 5? Be positive 1. And what do you know? The parentheses match. That's what I want to have. So here we are. This is really the reverse of what we did in section R3 today. It's taken, we started with, in R3 at 9 o'clock this morning, we started doing this in the parentheses and ended up with this problem as the answer. Now we're starting with the answer and ending up with the problem. So we're working it backwards from what we did first thing this morning. So that's what factoring is. It's it's not the inverse of multiplying, but it's the reverse of multiplying out polynomials. All right, let's look at maybe a shortcut that can help you a little bit, speed you up a little bit on some of these. X squared minus 8x plus 16. Three terms. I know I'm going to do X method. I can see that there's not a GCF. I know it's in descending order. So I'm trying to do X method here. And then, so I want it to multiply to be what? 16 and add to be 8. 8 and 2 would be too big, and it has to be 9. So there's only one other option, or two other options for 16. It's not add to be 8, but negative 8. Sorry, I forgot my minus sign. I was about to screw that up. Negative 8. So negative 8 and negative 2 would be positive 16, but that has to be negative 10, not negative 8. 4 and 4, negative 4 would be the right ones. And if I do the grouping here, I get x squared minus 4x. Not really much choice in what order, because they're the same number. And group. What I want you to see here is that you end up with x minus 4 and x minus 4. The correlation that I'm going for here is the fact that up here we have minus 4 and minus 4, and in here we have minus 4 and minus 4. That only happens when, what's in front of x squared there? There's a 1 right there. If there's a 1 in front of x squared, whatever your numbers are on your x are going to be the numbers in your final answer, in your factors. Like, if we go back up here, example L, we had a different number here. We had a 6. Notice the factors don't match what was in here. 10 and 3, there's not even a 10 in there, okay? If we go up here to example K, we got a 4 in the front. We don't have an 8 and a negative 3. We happen to have a minus 3, but we don't have an 8 right there. But if we go back up here to example J, what's in front of x squared? A 1. In our x, we have a 3 and a 4. Notice 3 and a 4. That is the shortcut that we can take, so that we would be able to actually look at a problem that maybe was x squared plus 12x plus 20. Set up the x for it. We want something that multiplies to be 20 and adds to be 12. It'd be 10 and 2, wouldn't it? That because there's a 1 in front of x squared, we could go straight and say, oh, that's x plus 10, x plus 2, and not even do the grouping on those problems. That if we had another one, maybe it's x squared minus 12x plus 32. So a minus sign even in the middle. Something that multiplies to be 32 and adds to be negative 12. Eight and 4, they both need to be what? Negative, because it's a negative that it adds up to be. And because there's a 1 in front of x squared, because that's there, that allows us to just go, oh, it's x minus 8, x minus 4. If there's a number in front of x squared that's like a 2 or anything else, you can't do that. But if it's a 1 in front of x squared, you can take that shortcut and go straight to your factors and not have to do the grouping. And that can help you a lot and speed you up on several problems as you go along here, that you can take that shortcut only when there's a 1 in front of x squared. If there's anything else there, you can't do that. So you gotta look at it and look for a 1 in front of x squared. All right, let's look at this problem, x squared minus 4. So changing gears, we've done the x method, we've done grouping. How many terms does that have? It has 2. So when we go to our rules of factoring, 2 terms, we're going to look at differences of squares or sums and differences of cubes. Well, what's on the x? What's the exponent on the x here? It's 2. So that's squared, right? So we're going to look at this. And in math, difference means what kind of problem? Subtraction. So to be a difference of squares, you have to be a subtraction problem. So this one has a squared and a minus sign. So that should tell us to look at differences of squares. And the way that you do differences of squares is you try to rewrite the problem as 2 things that are squared, subtracted. Okay. So I rewrite the problem this way. I take it, what squared gets me x squared, x. What squared would give me 4? 2. 2 squared is 4. If I can rewrite the problem that way, then there's a shortcut to getting the factors. One's a plus, one's a minus. If I multiply this out together, x times x is x squared. X times negative 2 is negative 2x. Positive 2x, they cancel each other out. And then 2 times negative 2 is negative 4. So if we can rewrite that difference of squares, then we can get the factors really easy. Another example of that. It's 2 terms. It has an x squared in it. What squared gets me 4x squared? 2x. What squared gets me 25? 5. I'm able to rewrite it that way. If that's not a square number, if that's 26 over there instead of 25, or if that's 24 instead of 25, I can't do it this way. But because it's a square number, I can do that. And my factors end up being 2x in the front, 5 in the back, one's a plus, one's a minus. All right. Oops. 25x to the 4th minus 144. So this is where it gets a little bit more difficult when they kind of try to disguise the squares. Because x to the 4th is not x squared. X to the 4th is not x cubed. So this doesn't seem to fit the difference of squares rule or the sum or difference of cubes rule, because it's not a squared and it's not a cubed. The key here is that it's an even exponent on the variable. That's a fourth. A fourth could be something squared, right? It could be a second power on that. What you can rewrite that as takes a little bit of thinking. 25 is easy. What squared is 25? 5. What squared would get me x to the fourth? Yeah, an x squared would get me. If I square x squared, that's x squared times x squared, which is x to the fourth. So that's the trickery that they're trying to pull here. What squared is 144? 12, yeah. Hey, I've rewritten it as a squares. So that means I can write my factors. One has 5x squared in the front. The other one has 5x squared in the front. They both have 12 in the back. One's plus, one's minus. Doesn't matter what order you put the plus and the minus in there. You put the minus in the front, plus in the back if you want to. In order to multiply to be a negative, what do you have to have? You have to have opposite signs. That's where that's coming from. That minus 144, that's why we got to have a positive 12 and a negative 12 to get the minus one in the middle. That's where that's coming from. Good question. Example S looks like a pretty basic one, but this one tends to cause a few problems sometimes for folks because it's got more than one variable, and they get a little nervous there. But it's still two terms, and this one would be a difference of squares because it's x squared minus y squared. Okay, so that what squared in the front, what squared in the back. Well, there you don't even have to rewrite that one. And I swapped my plus and my minus just for giggles there, I guess. Well, it really doesn't matter which one's plus and which one's minus. But differences of squares have a minus sign in the middle, and you can rewrite them as something squared minus something squared. If you cannot rewrite them that way, you still got to look for all those same things. You still got to look for GCF, still got to look for descending order. But if you cannot rewrite them as squares, like we've done on all of these examples here, then they're not differences of squares. Okay. All right. Now, let's look at sums and differences of cubes. And you may or may not have ever factored sums or differences of cubes. This is one of those things, just takes some memorization of a pattern. Okay. Sum, difference of cubes. And we're going to do a few of these, and then we'll throw it all back together, and the instructions will just be factor, and we're going to figure out what method we would need to use depending on what problem we're given. Okay. All right. So sum and difference of cubes. If it's a sum of cubes, so like x cubed plus y cubed, it's got something cubed plus something else cubed. The pattern, you've got a short factor and you've got a long factor. Here's the way that I always remember it. The short factor is the same. Okay? So if the short factor is the same and it's plus, then it's x plus y. We'll do some with numbers in it in just a minute to get there. The long factor is always the opposite. Okay? Long has an O in it. O is opposite. Okay? Here's how it works. In the short factor, you've already used one x, so you got 2 left over, so that's x squared. You've already used one y, so you got 2 left over, so that's y squared. In the middle, you've got both of them, and it's the opposite, so it's a minus here, plus there. We'll do several, quite a few examples here that incorporate, or a couple of examples that incorporate numbers to see what's happening here. So a sum of cubes, whatever cubed is in the front plus something cubed in the back, take that number or letter or whatever it is and just add them in the front for sum. Square in the front, square in the back. The reason this is a plus sign back here is because anytime you square anything, what does it turn into? No matter what kind of number, if I square it, it always turns into what kind of number? A positive number. So that's always going to be a plus sign right there. The sign in the middle is the opposite on the long factor. For a difference of cubes, x cubed minus y cubed. Same thing happens. The short one is the same, x minus y. The long one, all the pieces are the same. But it's got a plus sign in the middle. Okay. Learning those patterns. This is one of those things that you really need to, if you'll have that handy while you're working problems, and then kind of just memorize it. You can factor sums and differences of cubes. They're not going to get big numbers when you talk about sums and differences of cubes, because if you cube 2, you're already up to 8. If you cube 3, you get to 27. If you cube 4, you're up to 64. The numbers grow pretty fast with the third power. So they're not going to use really big numbers to do sums and differences of cubes. Let's look at an example or two of sum and difference of cubes with some numbers involved. So example T, x to the third minus 8. We'll use that one. Okay. We look at that. We follow our rules of factoring. First thing we look for is descending order. Check, it's in descending order. Then we look for a greatest common factor. There's nothing that's in common between x cubed and 8, so we don't pull anything out. The next thing we want to look at is how many terms. It's got 2 terms, so that should immediately point us to sum or difference of cubes or differences of squares. We know this should be a difference of cubes because it's got x to the third power. That's the clue. Okay, so that means I need to rewrite this as something cubed minus something cubed. The first piece is easy. It's x, because it's x cubed. What to the third power is 8? 2. So if I can rewrite it like that, then I know it's a difference of cubes. Then all I got to do is follow this pattern right here for the difference of cubes. The pattern is front minus back, square it, add everywhere else. Okay? So that would be x minus 2. And then I'm going to square it. X squared would be x squared. I'm going to multiply them together. 2 times x, 2x. Then I'm going to square the 2. 2 squared is 4. And I'm done. The great thing about differences or sums of cubes, this long piece back here will never factor. It won't ever factor any further. You don't even have to worry about it. You're done once you've done this pattern. This part won't work. Won't do anything else. Okay? Let's do one that's got a number in the front. 8x to the third plus 27. A little bit more difficult on this one because you got a number in the front of your x cubed and then a number in the back part too. But it's still the same idea. What you want to look at is the rules of factoring are descending order first. We've got that. GCF second. So 8 and 27 don't have anything in common, so I don't have a GCF. And then after that, I'm looking for a pattern, either sums, difference of cubes, differences of squares. 3 terms would be X method, 4 terms would be grouping. It's got 2 terms with a plus sign and an X cubed. That tells me it could be a sum of cubes. So I try to rewrite it as a sum of cubes. We already know that 2 cubed is 8. So this should be 2x in the front. What cubed is 27? 3. So again, short piece and a long piece. In the short piece, it's the same. So that's a plus sign in the middle. So it's just 2x plus 3. In the front of the long piece, you're squaring 2x. 2x times 2x, 4x squared. Minus, multiply the two pieces together. 2x times 3, 6x. In the back, square the 3. 3 squared, 9. You factored it. Really, the only other way to maybe factor this would be with using some multiplication type things or division, and we'll learn that Thursday. We'll talk about polynomial division a little bit. No, actually not Thursday, but June the 27th. We'll talk about some division. But if you'll learn these patterns, sums and differences of cubes are really straightforward and easy to do that way. Let's do a few problems in this section that are just mixed up, and we've got to figure out what methods to use to factor them. So the instructions are going to be factor, and it's just going to be everything, could be any particular type that we've talked about, okay? Yeah. All right. To get this part in the back, the long piece, remember the pattern is you square what's in front. So here we've got 2x is this piece. Right there's 2x. 2x squared is where this is coming from. This is actually 2x squared. 2x times 2x is where we're getting 4x squared. That's where that's coming from. Okay. And then the middle piece, we're multiplying 2x times 3. And it's a minus sign in the front. Okay. The 2x from the front, the 3 from the back, multiply them together for the middle piece always. And then it's the opposite sign. So it's a minus in the front of that. And then the back part is squaring the back part of the cubes. 3. They're squaring that. That's where those are coming from to get those pieces. Always going to be that pattern. The front part's going to be the front piece. Square it. The back part's going to be the back piece. Square it. The middle, multiply them together. Change the sign. Always going to be there in the long. Up here on example T, to kind of go through that same idea on it, you've got the front part squared, the back part squared. That's the front and the back of the long piece. Square the front, square the back. The middle, x times 2. And that plus sign that's right there, that plus sign right there is the opposite of this sign that's in the middle. Okay? So the middle piece, you're always multiplying front times back and doing the opposite sign. The long piece, you always square on the ends. Always square whatever's here. That's always what you're going to do. That pattern is going to be there every time. Take a little bit of practice. Sums and differences of cubes don't come up a ton, but they do come up some as we proceed through some polynomial stuff that we'll be doing later on. So being able to factor them can speed things up and make things work out a little bit better. It's just going to take memorizing that pattern a little bit, and we'll see some of the differences of cubes as you go through some of the practice problems. I think you'll see some. So let's look at just factoring. So the instructions are factor completely. We just got a few examples of that, about 5, and then we'll be ready to move on to the next section. We'll probably take a short break after this, go to the splash some water on our face and breathe a minute. So let's take this one, 5x squared minus 20. So let's go through the rules of factoring for each problem and get it factored completely. That means we got to try to factor everything out, not just doing one style here. So we look at this one, we say, is it in descending order? That's our first rule. Yes, it is. Okay, so if it's in descending order, the next thing to look for is a GCF. Is there a GCF? Mm-hmm. 5 goes into itself and into 20, so my GCF would be 5. What would that leave in parentheses? Minus 4. All right, 5 goes into 24 times. Okay. The next thing to look at is to say, okay, I pulled out the GCF. Is the stuff in parentheses, is it still, can it be factored using any of the other methods? So here I have x squared minus 4. That's got 2 terms and a minus sign in the middle, and the x is squared. So that could be a what? Could be a difference of squares. Can I write x squared minus 4 as something squared minus something squared? Well, be x squared. What squared is 4? 2. So yes, it is a difference of squares. Okay. So that means that the factors that go with that part, x in the front, 2 in the back, one's a plus, one's a minus, but we still have that 5 that we pulled out at the beginning. That's the factored completely form of that polynomial. We factored it all the way. We did the GCF. Then we did another method after that. It factored, because it would. They won't always do that. Sometimes you may only be able to do grouping. You may only be able to do the X method. But you've got to look to see if there's any other methods that could be done in order to factor something. Let's try this one, 10x squared minus 80x plus 160. So as we go down the steps of factoring here, we've got descending order is number 1. So it's in descending order. We're okay there. GCF would be the next thing. Is there anything that goes into 10, x squared, negative 80x, and positive 160? 10 goes into all of them. They all end with a 0, so I know 10 goes into all of them. So 10 would be our GCF. What would it leave in parentheses? Plus 16's right, yeah. Okay. So I pulled out the GCF. I'm left with something that has how many terms in parentheses? 3. So I'm going to try to do what method with that piece? I'm going to try to do the X method. So I need something that multiplies to be 16 and adds to be negative 8. This 10 is kind of hanging out here in the front, just watching what's happening. Okay. Negative 4 and negative 4. Can I take a shortcut on this one? Why? And there's a what in front of this x squared now? A 1. There's a 1 in front of this x squared. That allows me to take that shortcut and say, oh, I don't even have to do the grouping anymore. I just do this because there was a 1 in front of x squared. Technically, that's correct. You also might see that written as x minus 4 squared. That's the same thing. Oh, I got a dot right there. X minus 4 squared or x minus 4 times x minus 4. Those are the same answer. So keep that in mind. All that. Okay. And I didn't have to do grouping again because there was a 1 in front of x squared after I pulled out the GCF. All right. Example x. So we had x to the third power minus 5x squared minus 4x plus 20. What should I try to do on this one?
You gotta split it out into.
Okay, and that's called grouping. That's what she's saying, is grouping that. So split up into 2 pieces. What's the GCF of the first 2? X squared, leaving x minus 5 in parentheses. And what should I pull out of the second one then? Negative 4. Negative because of that sign right there. And 4 because that's the GCF. What's that leave in parentheses there? Another x minus 5. That means I did it right. The next thing will be my factors. X minus 5 and x squared minus 4. Here's where the factor completely comes in. X squared minus 4, anytime I see an x squared left in one of my factors, that should tell me to factor it a little further if possible, or try to. What do I know about x squared minus 4? That we've seen it already today, that it's a difference of squares. It's actually x squared minus 2 squared. So that means I'm going to have x minus 5, and then what are these other 2 factors? Because this is a difference of squares, I can factor it using the difference of squares method. X minus 2 and x plus 2. And there is one that's factored completely. Let's try this one. X to the 4th minus 16. I'm thinking difference of squares because it's got a 4th power instead of a 3rd power or a 6 or something like that. What squared is 16? Be 4, right? What squared is x to the 4th? X squared. So that means my factors are x squared plus 4 and x squared minus 4. Which one of those factors further? Look at example X. The plus 4 does not. The minus 4 would. It has to be a difference of squares to factor further. The plus in the middle there will not factor further. So we already know, we've done that one a couple of times today. We know the factors of it would be x plus 2 and x minus 2. And then that's the completely factored form of that. So that when you're factoring completely, you've always got to kind of look to see, okay, can I go any further? Can I take this apart any more than what it already is? And yes, we got through the whole alphabet in this section. So last one of this section, 12x squared plus 28x plus 48. What's the first thing we should look for? Mm-hmm. Is it in descending order?
Yes.
Yeah, we're good. Next thing,
Greatest common.
which would be
12.
12 goes into 28.
Okay.
Nope, goes into 24, not 28. Goes into 48, but not 28. So 12 can't be my GCF, so I got to have something a little smaller than 12.
So
Still got to do GCF first. Because I think,
I understand. You just make it smaller.
yeah, I just got to figure out the next number that's smaller than 12 that goes into 12, 28, and 48. So I'm thinking, okay, what numbers go into 12? 4 goes into it. Does 4 go into 28?
Yes.
7 times, right? 4 go into 48? 12 times, right? Let's make sure there's not something bigger. So the next biggest number that goes into 12 would be 6. Does 6 go into 28? No. So it can't be 6. It has to be 4. So my GCF would be 4. And then I'm going to pull that out. So then it'd be 3x squared plus 7x plus 12. Then I would try to do the x method. What goes on the top? 3 times 12 would be 36, and 7 on the bottom. So I need something that multiplies to be positive 36 and adds to be 7. So I'm thinking things that multiply to be 36. 6 times 6. That doesn't work. 12 times 3. That doesn't work. 9 and 4. Doesn't work. 18 and 2. Doesn't work. 36 and 1. Doesn't work. None of those work. None of the factors that make 36 will add to be 7. So that's the finished product. That's the factored form out of that. Always try the next method to go, that would normally factor something. If it won't work, then you're done. Okay, you go back to the last thing that worked. All right. One of the kind of a star note here for you on there. If no factoring can be done, the polynomial is prime. Okay, that's the word that it's called. If no factoring can be done, if you can't pull out a GCF, you can't do the X method, you can't do grouping, you can't do differences of squares, sums of cubes, differences of cubes. You can't do any of those things, then it's called a prime polynomial. Just like a number, like the number 7 is a prime number. It can't be broken down into other numbers. As opposed to 8 could be broken down into 4 times 2. 7 is a prime number. A polynomial that can't be broken down in any way is called a prime polynomial. Okay, it cannot be factored. All right. So there's section R4 for us today. So there's the first 2 sections. We've got 2 more sections to cover today. Let's take a short break, and then we'll try to get through these in the next hour and get out of here at 12 today if we can. So let's take a short break, run to the restroom, splash some water on your face, do whatever it is you need to do, and then we'll come back and get these last 2 sections and get out of here. A little easier lifting on the last two sections than these first two. So let's take a little break from here.